Everyone, so today we are going to solve another interesting problem, number 1011, capacity to ship packages within D days, and the problem is asking for us to return the least capacity of the ship that will be result in all the packages on the conveyor belt being shipped within days. So we have been given one list. We have been given one list of weights, and we want to ship all the weights in a given number of days, and the ship capacity should be minimum. So one thing I can observe and say that let's start shipping the weights by seeing the maximum capacity and the minimum capacity. So I can see the minimum capacity that can be shipped is 10, and the maximum capacity that can be shipped is the summation of all the weights. So which is 10 into 11 by 5 by 2, which is 55. So the maximum capacity is 55 and the minimum capacity is 10. And if I ship at this capacity, then the number of days that I require is total weight divided by the capacity. So that would be, the upper limit is 6, and similarly the number of days that would be required to ship the weight at maximum capacity is 55 by 55, which is 1. So our capacity to ship within 5 days should be somewhere between this 10 and 55, and we need to find that. So for that, what we could do is we can do a binary search in this region and see where our least capacity is and how we can get to it. So what we'll do is we'll keep one pointer on left and another pointer on right, and we'll find the mid value. So the mid would be 10 plus 55 by 2 integer division. So that would be 34. So now at this capacity of 34, we'll check how many number of days are required to ship. So for day 1, we can ship 1, 2, 3, 4, 5, 6, and 7, which is 7 into 8 by 2. That is 28 on day 1, and on day 2 we'll start from 8, 9, and 10. So that is 27. So we can observe that at capacity 34, we need 2 days to ship all the weights. So one thing is clear, that now to increase the number of days, we need to decrease our capacity. So for that, our solution would lie in this region or between left and mid rather than this region. So we'll shift our right pointer towards mid, and now again we'll do the binary search, same operation in this region. So that would be the approach, and this way we could reach to a minimum value at which we can find the capacity to ship all the packages within D days. So one thing we can observe is our problem function is monotonically decreasing. So that's why we are shifting our mid toward the right in the binary search. So here we are at R is equals to 55 and at L is equals to 10. This is our function of capacity. So at 10 we are 6, and on 55th we are at 1, and we need to find the days. We need to find the capacity at days 5th, so which is somewhere over here. So that we are going to find. So now let's get into the coding part, and I'm going to write my approach, what I have explained, and reach to the solution. So like we discussed, we'll keep two pointers at the minimum and maximum capacity. The minimum capacity is maximum of weights, and the maximum capacity is summation of weights. So here my L is the minimum capacity and R is the maximum capacity. And we'll check within these two regions using the binary search, like when left is less than R, we'll find the mid, which is the capacity, and we'll check at each individual mid values as we will be writing our search. So we need one function. So I'm going to name it like days taken to ship at this capacity, which is less than equals to number of days that we have been given. So we'll update our right toward the mid, otherwise we'll update our left, and in the end we'll return the R where we have found the minimum value. Now let's write this part of this function. So I'm going to say define days taken to ship at this capacity, and so first thing we need is the current weight for starting, so that would be, and the days taken. So initially there would be 0, there are no current weight, and days is 1. And now for every weight in from the weight array, I'm going to add that into my current weight so that I know that how many days are required for this capacity. And if this capacity current weight exceeds the capacity, then I know that I need to update my days and start the next day with this capacity of current weight. So I will increase my days taken by 1, and in the end we are going to return the number of days taken for that particular capacity. So now let's see how our solution performs. So it has been accepted for first test case. Now let's run the another example test cases. It has been accepted, and let's run for all the test cases. So it has been accepted and it's pretty fast. It's running great. So I hope you like my solution, and this is how you solve this problem. Thank you.